Hey everyone, here's our math problem for today. This is taken from the PUTNAM math competition in 1993. Here's the problem. A horizontal line y equals c intersects the curve y equals 2x minus 3x cubed in the first quadrant as in the figure below. Find the value of c so that the areas of the two shaded regions are equal. In other words, we would like to find what is the equation of this horizontal line that will make this area below y equals c and this area above y equals c be equal. You can pause the video and see if you can solve this difficult math competition problem. Now let's solve this problem together. The first thing that we are going to do is let's identify this point of intersection between the curve and the line y equals c. And let's denote that to be x equals d. Then since we would like to find the area under the curve, we can use definite integration. So notice that there are two parts in this area. One is from this point, which is x equals 0, and up to a certain point here, which we do not know. We do not know what is the value of this x. Now in this left part here, notice that the line y equals c is above the curve y equals 2x minus 3x cubed. Now after this point and going to this other point here, we have this area above the line y equals c. And notice also that at this region, the curve y equals 2x minus 3x cubed is above the line y equals c. In other words, if we write the function y equals 2x minus 3x cubed first and subtract the function y equals c, then the area that we will get here is, in this left part, we are going to get a negative area. And after this point, the area would be positive. Because here, the curve is above the line, whereas here, the line is above the curve. And since these two regions have the same area, with opposite signs, then their combined area must be 0. That's why we equated this definite integral to 0. Now let's compute for the antiderivative of this function. The antiderivative of 2x is 2x squared over 2 or x squared. The antiderivative of 3x cubed is 3x to the fourth over 4. We copy the sign. And the antiderivative of this constant c with respect to x is cx. And we are evaluating this from 0 up to d. Then copy the right side. Now substituting the value of d and 0 for x, we now evaluate this definite integral as d squared minus 3d to the fourth over 4 minus cd. Then simplifying this algebraic expression, let's add cd to both sides of the equation. Then let's solve this equation for c. Let's interchange the left side and the right side of the equation and divide both sides by d to arrive at c equals d minus 3d cubed over 4. Let's remember this value. Now, let's go back to the two given functions, y equals c and y equals 2x minus 3x cubed. Let's solve these two equations simultaneously, and we now have here an expression for c in terms of x. But what we have here is an expression for c in terms of d. And so, evaluating now this equation at x equals d, because d is a point here. And so, at x equals d, the value now of this equation is c equals 2d minus 3d cubed. That is because we define d as the x-coordinate of the point of intersection between the curve and the line y equals c. And this point has a coordinate of x equals d and y is equal to c. So we now have two equations in terms of c, which we can now solve simultaneously. Solving these two equations simultaneously, we can combine like terms. So 2d minus d is 1d. Negative 3d cubed plus 3d cubed over 4 is now simplified like this. The LCD is 4. So 4 divided by 1 times 3 is 12, copy d cubed. 4 divided by 4 is 1 times 3 is 3, copy d cubed. Then let's be careful with the sign. When you distribute the sign, you still get minus and plus. Then 12d cubed minus 3d cubed is 9d cubed, copy all the rest. And simplifying further, we now have this expression 4d minus 9d cubed at the left side, and that is equal to 0. There is a common factor of d, so let's factor out that d. And the second factor is quadratic, which is also a difference of two squares. So from here, we know that d is equal to 0, and 4 minus d squared is also equal to 0. And solving for d, we have d is equal to plus or minus 2/3. So we have three values now for d. D equals 0, d equals positive 2/3, and d is equal to negative 2/3. But the way we define d, we know that d is not negative because we are in the first quadrant. Therefore, d equals negative 2/3 is an extraneous root. Also, d cannot be 0 because 0 is here, d is obviously not equal to 0. And therefore, there is only one acceptable value for d here, which is d is equal to 2/3. We have the value for d, but what we are looking for in this problem is what is the value of c. So let's recall what's our expression for c. We said a while ago that c is equal to 2d minus 3d cubed. Now substituting the value of d for this equation, we now arrive at c equals 2 times the value of d, which is 2/3, minus 3 times the value of d, which is 2/3, raised to the power of 3. Simplifying, we arrive at this computed value. And further simplification, we found out that c is equal to 4/9. And so going back now to the main question, we would like to find the value of c so that the areas of the two shaded region are equal. We just found out that the equation of this horizontal line must be equal to y equals 4/9. And when that happens, this area at the left side of this point of intersection and the area from here up to x equals d are equal. And if you are curious what is the value of this point of intersection, although it's no longer necessary in this problem, we can solve again this equation y equals c and y equals 2x minus 3x cubed simultaneously to arrive at this equation. And solving for x is equal to -1 plus the square root of 3/3, or approximately equal to 0.244017. That is the x value of this point of intersection. The y value is 4/9. So for our final answer, c is equal to 4/9, and this problem is now solved.